Do you see it?
Yeah.
Okay. I think it started.
Yeah, I think we should. Yeah. 3 minutes. There's no one. But anyway, it's not session after we can 5 minutes long, and we can skip one slot in the presentation, so we have 10 more minutes. Which is layer 1 culture. What's that? I saw they were
just giving away books about Korea. Did you? That was videos. At lunchtime. This lunchtime they were showing some videos downstairs about Korean history. I watched some of those, and then I said we're going to give away 3 books about Korean history. This is King Sejong. The greatest Korean.
The second one.
It's a Mac.
Thank you. If you want to take some notes. Okay. I always do during the sessions. And we have I'll take one back. Sure. We are already late?
Yeah, I should have started 3 minutes ago. So
That's what I said. Let's start.
crack on.
We don't do the ether capture. Who's going to do that? I guess I will. Great. I'm missing. Okay. Obviously, it's on the other side.
Of course.
Okay, just a spot. That's okay. I have to duplicate, otherwise I can't see anything. Hello, everyone. Let's start, even if these kids are going long. This is the Ccamp session, but it's a joint session between the Ccamp, TIS, PCE, and MPLS working groups. the idea is to cover all the topics related to young modeling that have impacts on the 4 working groups. IETF not well, since we are at the beginning of the week. Let's have a review. Actually, by participating to the IETF, you agree with the IETF process. Please keep this in mind. It means that if you are aware of contributions covered by patents applications, you need to disclose that. You need to understand that meetings might be recorded, broadcasted, and publicly archived. This is our case since we are being recorded. So please speak to the mic, say your name before making any question, comment, and so on. Minute takers and Etherpad, Lou volunteered to help us with that. If anyone is willing to help us, please use Etherpad together with Lou and us. Sessions. We will have two Ccamp sessions this time. One is this session, again dedicated to young modeling. We will have another one on Thursday, more dedicated to Ccamp specific stuff. It will be on Thursday at 1:30. Agenda. Pretty full agenda. We will start with working group items from the PCE and TEAS working groups, then MPLS with MPLS, LDP, and MLDP. And then we will go to more technology-specific requirements like the NBI for transport networks, young data model for OTN, and so on and so forth. Last but not least, a reminder for all the IETF participants and a piece of information for newcomers. I don't know, Lou, would you like, since this is your slide, would you like to go through it and remember us the split of responsibility between the different working groups?
I'll do it from here. Hi, I'm one of the co-chairs of TEAS, Lou Berger. While I put the slide together, this is really coming from the area directors of when they reorganized the groups. So I may be talking, but this really isn't my structure. It's a structure all us co-chairs here are living within. And it's just good for the all groups, all participants, all contributors to know about it, because it's a little confusing, and frankly, it can be it's confusing to us as to sometimes what group things should go into. And I'm not sure which direction to go in here. It's a little bit of a circle. Basically, we have each group is responsible for a particular protocol, but then we have overlap between each other on things that we have where we have to coordinate. And particularly it's in the area of traffic engineering where there's most of the coordination. So we have MPLS that owns LDP and the MPLS data plane. We have PCE that owns PSEP, Ccamp that owns LMP, and TEAS that own RSVP-TE. And those are the protocols that each of us own. The problem is we all have to work with each other. Particularly RSVP-TE is split on 3 groups.
So now it works.
And now the area director comes in. But I'll be fair. She didn't come up with the structure. She's living
exactly. The problem is that it's the new one.
So the key thing to remember, the key takeaway I have is that TEAS, and I'll start there because I'm a co-chair there, worries about generic architecture. So if you're worrying about common function, it goes into TEAS. Also, if you're worried about architecture issues, that goes to TEAS. If you're worried about some specific protocol implementation, let's say a PSEP extension, that goes into the respective working group. So PSEP That's really easy. And if you're doing something that's technology specific, you go into which group? Well, you have to know which technology you're talking about. If you're talking about packet, it goes to MPLS. If you're talking about something that's not packet, it goes to Ccamp. And the big challenge here is to figure out when something is generic and when it's not. And the reality is that whenever we come up with proposals, we're trying to solve a particular problem. So generally the proposal starts out as being technology specific. And then at some point we have to take a step back and figure out it's generic. I've talked enough on this, I think. So anything else?
Try if it works.
Hi, I'm Dhruv, and on behalf of my co-authors, this is PCEP Yang. So just a quick recap. So this Yang model is for management of the PCEP speakers. So we are basically dealing with the PCEP protocol configurations and PCEP protocol state. Okay, perfect. And the base that we wrote when we first proposed this Yang model was focus only on the base 5440 RFC. And we had the MIB already by the time. So we made sure that our original Yang was aligned to MIB, and all the attributes that are defined in MIB are somehow mapped also in the Yang. But over time, we have added and all the various extensions that are ready, especially the stateful extensions to PCEP. Those have been added in the Yang model. We also have segment routing, as well as some older extensions like SVAC, handling of objective functions, P2MP, etc. So what did we change since we got adopted? And the main things that we fixed was because of the new compiler that got added, we were throwing some errors, especially conf.dc. So those we fixed. We also added stateful PC synchronization optimization, that if a PCEP speaker supports this optimization function, what are the changes that we need to add in the model to support it. Handling of objective functions and handling of path keys. Path key is the confidential mechanism that the PCEP has when it wants to hide the internal details of the domain. So that changes have also been added in the PCEP Yang. So let me go one by one. In case of sync optimization, the main changes that we have to do is we have various optimizations, like include which is whether when we exchange LSP state, would we include the DB version, whether we support incremental DB delta sync. That means when we do state synchronization, whether we will send all the LSP DB or whether we will only send the changes. We also have two operations, whether we support triggered sync from PCE as well as triggered resync from PCE. So these all capabilities are defined in a working group draft called state synchronization. So we made sure that our Yang model can handle it. So the only changes that we have done so far right now is the capability part. That means whether the local entity supports these capability as well as whether the peer that I'm forming the session with supports these capabilities. Those we have added. I also got a comment from one of our co-authors that maybe we need to also take care of the RPC. That if I want to trigger the resync, I should have a function in my PCEP and RPC exposed where an operator can trigger the resync function. So anyway, I will discuss the RPC notification in the later slide. This is an action item for me related to sync optimization. Continuing on, we also need to worry about some other parameters that needs to be maintained. The first is the DB version. So we have a local database version. So where we store the LSP DB, we will be maintaining a DB version. Similarly, for every PCEP session, the DB version that we receive, that needs to be maintained. This information will help us to figure out whether we can skip synchronization or how we do the delta synchronization. So for that purpose, we need to maintain this information in our PCEP Yang. We also have a feature that in case the IP address of the PCEP changes, But since we have another speaker entity, which is something which will remain constant and will not be dependent on the TCP session IP. So that feature, to handle that feature, we have the local speaker entity, so which is also something that we can store, as well as the entity ID that we have received from the peer that we will store and show you in the YANG. The objective function, this is as per 5541. So what do we need to put it in the YANG? Since 5441 says that when you send an open message, you need to include what are the kind of optimization functions that you support. And that information is the one that we are currently storing. So, and each entity exposes that these are the objective functions that I can do. And when he makes a session with another PCEP peer, he can carry that information. Similarly, we maintain a list of all the objective functions that a particular peer supports. All of this is as per the manageability consideration of 5541. Path key. Now, path key brings in two things. The first is when we configure a path key, we need to have some parameters. That is how long we will maintain this path key, when will we start reusing it, what is the ID that I will use when I make the PKS object. So all that information is configurable, and thus it's part of the config path key. Also, as per 5520, we should also expose the mechanism for an operator to see what are the path keys currently generated by me. So that state is also available here, where we have a list of all the path keys and the confidential path segment, which is nothing but the ERO. So this type is borrowed from the TEAS draft, but it needs to be maintained right here because it's the PCEP which has generated it, and it needs to maintain this CPS and the relationship between the path key and the path, and also other parameters like whether it has been retrieved yet, when was it created, when will it be available to reuse, all those parameters. And all of this is actually very well defined in the 5520, and we have just followed the manageability consideration section and implemented this in YANG. So these were the three main changes that we did, but we still have some open comments from some people. The first is last time we added authentication, but something that we have missed out is TLS, the configuration of TLS. Configuration of TLS parameters. So for this, we definitely wanted to use an existing YANG model somewhere where those things are well defined, and we simply use it. So we are still figuring that thing out, what will be the right place and right way to do it. And also we have a discussion on what kind of notifications and RPCs that do we need to expose. So we have done a lot of config, lot of state information already. The thing that we are still lacking is notifications and RPC. So that is a discussion that I would like, and any feedback on that would be very useful to us authors. Also, we want to figure it out that we have added a lot of extensions. We are right now supporting almost all the important features. So, but we still know that some of them are pending. So should we, what I want to figure out is when do we stop? Does this PCEP YANG needs to have almost all the extensions that are currently defined and I should stop them? Or should I sort of freeze now that the major features are ready and just polish them? Because right now itself the model has gone a little bit big. So how do we move ahead? That question I would like to ask the working group. And of course, reviews and comments and contributions are always welcome. Thank you. Any questions or feedback on these?
Hi, Lou Berger. So I think this is a really good question. A general one is when to stop. And I think we're having this now in multiple drafts that we're going to hear about today across the working groups. And I think it's one that we started talking on this morning in TEAS, and it would be good to come up with a consistent answer. And from what we talked about earlier in TEAS was that it's sort of good if you have something that's core, start moving it out. And we have a couple of TE documents that have a lot of different pieces. And my original thought was that we would just take the document, cut the stuff that's not as stable out. But the author mentioned another idea, which is take what's good, pull it into a new draft and publish it, and keep the other document that you have as for where new stuff comes in. But either way, we should figure out how to start publishing things that are stable rather than waiting. And that said, as a contributor to the PCE document and as a chair in the for future TEAS documents.
Xifeng Liu from Quattro. And for the second item, for the notification, and have some suggestions for the topology model and the T-tunnel model. Currently, we are trying to avoid the model-specific notifications because so if you do that, your complicated model, you need to define all kinds of notifications. You don't know what you need to cover. So to make it simple, we use the YARN push and the subscribe mechanism. So if it do that, then for this particular model can be really simple. So just to suggest to think about that, see if that applies to you.
Thank you.
Stefan Nikowski from Orange. Regarding stopping or not, just one advice. Maybe it would be good to wait for the stateful PC draft to end the last call. So we are sure that we are stable in terms of behaviors and especially features and so on. And then it will be time to stop, I think.
Yeah. Thank you. I think it's Rakesh.
Xifeng is presenting next.
I'm Xifeng Liu, reporting the status of the TE topology models on behalf of the authors and the contributors. Since last IETF, we have done several changes. And here is a list of changes. So the changes we getting smaller and smaller. So the model is getting not stable now, so we're trying to close down the necessary future changes. So we hope this will be pretty much all we need to do. So since last time, we changed several issues here, including notifications, scheduling, information source, bandwidth, and some remove some technology specific attributes, and also added to complete the model, added the statistics, and also completed the connectivity metrics and the local link connectivities. Based on the feedback from operator, we also added the geolocation information, so some model improvement for the keys. And we are talking about the MDRG. We'll talk about that later. This is still being discussed. We haven't added to the model yet. So for the notification, we just mentioned that during Joe's discussion. So we used to use the model-specific notifications, so that we have to define a lot of notifications and complicated models. So it's not flexible. So we decided to use the YARN. There's two new drafts in the NetConf for the notification subscription and YARN push, so push notifications. And here on the right side, that's the model from the subscription. So on left side, that's our topology model. So we took out the notification definition we used to have. Then we use this subscription model. We can have the filter pointing to any particular object we want to have notification to be pushed. and then we specify how do we have that pushed and what attributes we need to include it. They have a filter. So this is very flexible. So we're trying to go this way. On a similar idea, for the scheduling, we used to have a grouping in the model to specify which kind of resources we can schedule at a particular period of time to have that configured or deconfigured. So that we have a grouping for that scheduling model. So that model was presented to NetNode, and we got feedback about this kind of intrusion to the model. Why we need to use this? You have to modify the model. You have altered whatever model you want to have this feature. So we applied a similar idea to the subscription notification, and we have this model separate out. So you can have this XPath pointing to whatever the object we want to have the configuration scheduled, and then we can apply the scheduling without changing our original model. So another thing here will be the some information source. Basically, this is just a bug fix. We align to the current the two because of the IETF routing config model has been involved recently. So we don't have routing instance anymore. So we now align with the logical network elements and the network instance. We added the missing portion, like the node reference and the link reference. So those references are needed when we trying to retrieve the information where it's coming from. So in this case, so we're trying to merge two topologies from two domains, and like the I17, which is coming from I7, so we need to know where the node is. So we have that node reference. And for the bandwidth, so we're trying to, in the generic topology model, we have a generic bandwidth. So to accommodate different kind of technologies and different kind of encoding types, so that the current proposal is that we use this generic bandwidth, so which can be applied to either packet or OTN or DWDM, so which is a string with a certain pattern. So it's kind of similar to some other YAN types defined in the YAN types, like INET types. So, but we have our own purpose, so we're trying to do this. Then for some of the technology-specific attributes, we remove them from this generic model. Thanks for comments from Dieter and others. So we now remove the performance metric, move that to the packet topology model, and we also remove the Sonnet SDH kind of attribute here. Then to complete the model, we added statistics. So we have node level statistics for each kind of the counters for node level, and also the link level statistics. Then for the connectivity matrix, we have the model completed. So here, the line here from the right line here, that's the connectivity matrix entry, and underline to implement that. So in the case of abstract topology, we may have a path, underlay path. So in that case, it's pretty much like a link. So in that sense, we added pretty much all the attributes same as the TE link. So they are consistent and all the same. Similarly, for this kind of connections, we do the same. So we have all the attributes same as the TE links. So this relationship is from tunnel termination point to the link termination point. So that's the very to and edge side, the ingress or egress. When you have this tunnel terminated, we have those attributes. Yeah. I mean, okay. Sure. Okay. Based on the operator feedback, we added the geolocation information. Then this is also from the feedback from the implementation. So it's kind of difficult to query based on the TE alternate keys. In particular, we have this TE node ID and the provider ID. So we move them a little bit to the upper level so that we can easily use the XPath to do the query. This topic we are still discussing, and we're trying to add to the model so that here when we trying to in the abstract topology, if we want to configure two abstract links, the underlay path sometimes we want them not share the certain risk factors. So this update of the SRG. This is needed in case we want to have a pair of links for the protections for other cases. So we're thinking to add this to the model at the TE link attributes. The modeling is simple. So we just add the attribute pointing to the IDs, and we define a group saying that what kind of disjointness we want to have node disjoint, link disjoint, or SRG disjoint. Next step will be have further review, and I think the model pretty much stable, so we should be able to finish that soon.
Jason Stern, Nokia, I had a question about early in your slides you mentioned you removed the notification.
Right.
So just so I can understand, so you've removed the notification and instead you're just going to rely on subscription methods to subscribe to various state nodes in the model.
Yes.
Okay.
Yes, exactly.
That's kind of interesting. I was wondering if that's something. I wonder if that's something that's kind of a more generally applicable to a lot of models now. A discussion we should be having.
Yes.
That's a general approach we should be using rather than putting notifications in that just notify about a state change.
Right, unless you have a model-specific notification, you have certain format you want to use that. In that case, you still want to use the model-specific notification. Otherwise, generic works fine for us.
Okay, thanks.
What are the implications of this choice?
What kind of notifications?
No, the implications of this choice. Faster, slower,
more flexible, more powerful, and it's cleaner to the model also.
Hi, Lou Berger. I wanted to push back on your removal of metrics, performance metrics to packet. I actually think that is a
generic enough.
What?
Generic enough?
No, it's a generic. It is a generic capability. For instance, if we've done Ethernet previously in Ccamp, and if we wanted to do Ethernet TE, you would want to have those metrics. But I also think it's reasonable to say maybe we should have a middle ground between putting everything in the generic model or putting it into the technology specific. Maybe there's a middle ground of you defining groupings for things that may exist in a particular technology. Well, I don't like groupings because you have the reuse problem. I'm designing on the fly, that's always dangerous. But maybe there's a middle ground to deal with something that doesn't show up in all technologies, but shows up in more than one. Because I really think that this is the case we have here. So while you've taken it out, I think you're going to cause us problems down the road. Like, and in another working group, DetNet, we're gonna need this. So I'm a little bit concerned about that.
Yeah, when we discussed, there are different opinions, and so this is mostly from the OTN and the optical side. But
So-
personally, I don't have strong opinion. But
So what do we do with things that are apply to more than one technology, but may not apply to all? I think it's a good discussion. I don't think cloning the same information in all of them is the right answer. If we had groupings that were augmentable, I'd say yes, just use a grouping. But since groupings aren't augmentable, we can't.
Groupings, we are already using groupings, but if you use grouping, it's always there. So we can use a feature to make it optional. Then
I think that's an interesting approach. That might be something we should talk more about on the list. And maybe that's the right way to handle that. But we should have an answer for across the groups.
Right.
Another really minor point, you're definitely not using LNE right, and you may not be using network instance right, so we should talk about that.
Okay.
Dieter Bell, Nokia. I actually made these comments that we should take out the technology-specific metric attributes out of this draft because, well, specifically we were talking about things like packet loss, delay variation, etc., and those are not applicable to transport technologies. And so therefore, I was of the opinion that these should be defined in technology-specific augmentations.
I think it depends on which transport technology you're talking about. There's more than optical out there.
Okay, Fatah speaking. So could you go back to page 7? So yes, I agree that it's very convenient to use the integer numbers to indicate the audio signal types. But actually, I think you missed some information for OTN switching. So for example, for the beyond 100G OTU-CN, how can you encode this kind of information? And another comment is about DWDM. So even we use this kind of approach, but for the fixed grid and the flash grid, they have different slot granularity. So you should differentiate this kind of information.
Just two numbers, right? Do you have
number,
do you have an
two
example?
types of
Yeah, but that's fine. You have a list of numbers. You have this position, so you can have a first number as a type, and then you have.
No. You just indicate slot 0, but you don't know which kind of the slot.
Then, so how do you do that? How do you encode it?
You can just anyway, very simple. Just add another piece of information. For example, slot granularity type.
That's another number.
Yeah, another number.
So they're still covered. So I can fix this example. So if you have that,
But
then you have.
I can say how you can do that. Yeah.
Yeah, you add more numbers, right? So this can be infinite.
But right now you only have 2 numbers.
Not necessary. You can have an infinite list of numbers.
Are you list? So for example.
So 0, 2, 3, 1. You don't have to stop there. You can add 5, 6, 8, 9, 10.
I know,
Continue.
but anyway, you should have some kind of rules, to define, the list of the numbers. Otherwise, the people how we can, interpret those kind of numbers.
You have to define what the meaning for each particular number.
Yeah.
The type. The type is a number.
Yeah, I agree. Yeah.
Then you have type inserted in between the slot and.
I mean, actually, for this example, for example, you have 2 numbers, number 0 and number 2, to indicate that this is the slot 0 and the slot width is 2, right?
Mm-hmm.
But this information is not complete.
So you add
right.
So you can add a type before the 0. Let's say type 1.
You mean you use type 1 to replace 0? No.
Yeah, I think
No,
I think
no,
we can take I think we can take this to the list.
Yeah.
Okay.
This is a
Quick,
generic
have
bandwidth,
the
and then
example,
Shufeng can send examples on how
Yeah.
this can be augmented.
But generally, I would be opposed to having a list of things that are not exactly the same. That, you know, it should be a list of tuples, or it should be, you know, handled some other way. But to have two numbers in a row mean different things, I don't think is a good idea. So to slot and width, you know, there's no difference, it's just numbers, you know.
You have better proposals.
I have better what?
Better proposals other than this. So we need to be generic. Sometimes we only have one number, so which is a floating.
The syntax of
Yeah.
0:1, comma would be better.
Shufeng, you have 5 more minutes to.
Okay. So for the layer 3, yeah. So we change the align with the current IETF layer 3 topology model because they have a newer version. So the hierarchy is still the same. They have name changes, and we renamed the model from the I don't know, PSC. Yeah, used to call PSC. Now, based on the feedback, we call it packet now. And then we have added a new attributes mode from the generic topology. So this may be reconsidered based on our previous comments. So next step, this model, I think we need to have a further review and for working for production. Then we also have SR and SRTE. So for this model, we did the same to align with the current version of the layer 3 topology model. And also we did some changes to the SR model. There's a segment routing model existing in segment routing working group. We're trying to use some of their groupings because the current structure, we couldn't use that. So we work with those authors, and we split the segment routing model. So we have the shareable groupings into a separate independent model. Then we can share all the groupings from there. So to simplify all models and make it more consistent. That's about it. We have some items need to finish. So for that model. So that's all for.
Hi everyone, my name is Rakesh Gandhi and I'm providing an update to the TE and RSVP Yang data models on behalf of the authors listed. We also got good contributions from I think Sergio from Nokia, Sian from Huawei, and Michael from Nokia as well. So many thanks to everyone who is contributing. So agenda is as following. We'll look at the updates made to the model since last IETF. We discussed the open issues this morning in TEAS, and we'll look at the next steps. So RSVP model has been pretty stable since a couple of IETFs. There was a small change we had to make to fix a compilation issue due to dependency. We made a few updates to the TE model. First one being a few small changes. One, there was a typo in the admin group. We separated the P2MP and the P2P TE tunnels. We used to have key and type, and now, we used to have name and type in the key, and now only name in the key.
And just like RSVP, we fixed the compilation issue. We added path constraints. There is a new type, the hop limit. We also defined the optimization criteria, the minimum number of hops, latency, and the cost. The work in progress for the RFC 5541 objective functions is being discussed, just like the PC and other models. We have added compute-only tunnel support. Basically, idea is that client provisions compute-only tunnel with set of paths and preferences and constraints, and identifying compute-only per path. And when server computes the path, the state is stored in the LSP, but there is no signaling, or there is no resources committed or reserved. And when the paths available, is clients notified either via polling the server or PubSub.
So this one is the stateful computation, right?
So these are stateful computation in the sense that if there is a topology change, or there is a better path, it will be reflected in the LSP. So there is a debate on the mailing list for this edition. We'll see where we converge. We have added support for the RPCs. The new Yang 1.1 allows RPC. So we added new actions. There is a reset for tunnels, reoptimize switch path, and a compute path. So the RPC is returned immediately with success, failure, or in progress, and you get the results sometimes later on. So we have few issues we discuss, open issues discussed this morning in TEAS. First one being the technology specific packet or optical, how do we handle it? This was presented in last IETF and is still open. The authors are working on support for telemetry counters as well. Bandwidth type, I think we had good discussion on the topology model. They have added the generic and the technology specific bandwidth support. And basically we need to change the team model to use the same idea. So next steps for us is to conclude on open items, request further review and address comments. We're also working with the PCE Yang model authors, the PCCT data. We had some good discussions this morning. We're not there yet, but there is definitely a good chunk of work required there. Thank you. Any comments, suggestions?
So for that, so just one quick comment. So for the compute-only tunnel, so you just mentioned that it is stateful, right?
Yeah, the result is stored in an LSP container, and every time there is a topology change, that it gets updated.
Yeah,
so
I know. Actually, I saw there were lots of the discussion on the list, but I don't think we got consensus, right?
No, not yet.
But you already updated it.
Yeah, so this got updated in the draft based on the authors, the weekly meeting and agreement.
I think changes should be based on the WG consensus, not based on the authors' consensus, right?
Definitely. So this is one being controversial. So we will update the draft as soon as we have consensus.
Okay. Yeah. Thank you.
Dhruv from Huawei. I also wanted to mention that what we decide here would also impact the PCE architecture, because we don't have anything like this kind of computation in PCE. We have a stateless, or we have a stateful. We don't have a stateful compute. So if we decide to do this in Yang, I would like, maybe it also needs to be applied to whether the PCEP protocol also needs to support a similar feature. So we need to actually continue to discuss this and conclude together that whether this is needed or not.
Does this mean that you don't want this extension in PCEP?
I'm not sure yet. I'm still.
This is Young. I have one comment. When you do compute-only tunnel, and then there's no commitment from the user, when you update Yang store based on that, would that be a valuable thing? Because you don't, your data store updated, but the resource is not taken by other clients. Do you think this type of mechanism is valuable? In my opinion, it's not.
Okay.
I mean, that's a debate, right, on the mailing
That's the
list.
debate, yes.
And we can actually ask this working group, what's kind of the people's opinion on that. I know your authors kind of agree on this one, but rest of the working group list kind of oppose that.
Right. Yes.
Yeah.
Sergio Belotti from Nokia. Just a couple of points. We provide to Tarek a list of comments, me and Xian.
Xian, yes.
Not all are already, these slides are not updated.
Right,
Till
yes.
the last comments in which Tarek agreed that need to be updated
Right.
along this, what is required in our comments. So this is just for the audience that
Right.
here there are no that point.
Yes.
Another point in the slide regarding the RPC is mentioned the action proposal. So Tarek confirmed that the model actually already is, there is predisposition in the model already also to support classic RPC. So the decision has not been taken yet.
Okay. Yeah. Any other comments, suggestions? Okay, thank you.
Shifeng?
So I'm Xifeng Liu. Now talk about the status of the Yang data model for RDP and MRDP. So this is a current draft MPS RDP and MRDP Yang. So the history of this draft used to be up to the blue here. So our individual drafts, and then this draft was adopted during last IETF in August. So now it's a working group document. Then we have addressed most of the MPS RT comments. So the draft was reviewed by MPS RT, and we got comments. We addressed a lot of the comments. There are still a few comments pending. So that's what we're here talking about. So the current, the adoption pool happened during the last IETF, and the version was posted in August. Then here are some leftover comments. One is that the document is getting big. So there are 114 pages. And so that triggers discussions. So should we split document or not? So based on the consensus, so we are working on to split the one document into two. One is for RDP, so that's a base RDP model, and then another one for MRDP. So add the multicast capability on top of that. So the split document, we have that finished, and so it is posted now. even though the model is splitted, the structure has not been changed. They kept the same, but just cut into two pieces. One in the base RD model, another one in the MLDP model. So that's for one comment. Another comment would be because of we mentioned that the model is big, and the comment saying that because it included too many features, too many objects. So the team currently is reviewing all the features and objects, so trying to cut down some of them. So for the vendor specific, we remove them. For some features, we're trying to split them into base feature and extended feature. So that work is still going on. It's almost completed. We separate into two categories. And after this IETF, we will be able to finish that soon and so organize the model a little bit more cleaner, so that for the base model it will be much smaller, and then for the extended feature we'll have another model to augment the base feature. Here all the open items we have for now. The first two highlighted here are pretty much done, so we are trying to finish that pretty soon. So after the IETF, probably we can post it sooner. And also, we also need to consider how do we, if we need to adjust the model structure for the operational state. For now, seems like we don't need to, but we depend on the discussion. And also, we need to go over, re-examine all the default values, see if we need to have the model to cover those, especially those explicitly defined in the RFCs. To complete the model, we also need to add the statistic information to the multicast, the MLDP, RSP, and bounding. So there are already some pieces of the statistic data there, so we just need to complete that. Right, like mentioned, the new version already split into two. And then next step will be partition each of the two into base and extended, and align with the open state if needed, and address any open issue comes up. Any question?
Would the base model have any features at all?
Base model. Do we have? We haven't write the model yet. It's probably we don't have feature, right? Yeah. Yeah. That's what you hope for, right? Yeah.
AC Lind of Cisco Systems. That's an interesting convention to keep the base models without any features and put them all into into a separate model that augments those modules in the base modules.
Mm-hmm.
And I'm wondering
if
we should do that on a wider basis.
Yeah, I think there's merit in making that a convention.
But then you need to go over those other OSPFs again. So I don't know if you want to do that.
I don't think any of my co-authors are in this room, but I know they don't want to.
It takes a lot of time and discipline to do it this way, but the end result is good. It simplifies model, and it could be really good to consider it having across.
All right, thank you.
AC Lindum again. So in the model with only the features, you still keep them as features, right?
In the extended model, we still have features.
You still have them as features. Okay, yeah, because then otherwise you'd need unique sets and you'd need multiple
Right,
drafts, like
right.
almost one draft per feature if you did,
Right.
or one augmentation per feature if you didn't. Okay,
Right.
thanks.
Good afternoon. I'm Sergio Belotti. I'm presenting an update for the gap analysis, young gap analysis, on behalf of co-authors, in particular Xian, that was not able to join us in this meeting. Okay, so the goal, this draft has specific goal. The goal is analyze existing models that can be used in northbound interface between domain controller and an orchestrator against specific use cases that has been identified as typical in the context of transport traffic engineering network. These use cases are single domain network, multi-domain network, and multi-layer network. And the scope is to analyze this model, identifying possible gaps, some attributes, some information missing. And basically, the scope is providing a guideline for possible needs for augmentation of existing model or for a new young model. This absolutely known goal is the controlling device interface protocol. So this is the status of the activity related to these drafts. So we have finished the single domain already before IETF in Berlin. We provide a set of comments for TA tunnel model, and we already submitted the OTN tunnel model. We have finished now the multi-domain and multi-layer analysis use cases, and here we have provided a set of comments that I mentioned before related to the TA tunnel model, and we have already held some talk with discussion with the TA topology authors on the multi-layer case aspects. All the information and material related to these drafts and related to this activity, because this draft collect practically an activity, a weekly activity on the group of authors, and is in this GitHub address. With respect the last version, the update in this version 1, okay, we had added the reference at the GitHub. We updated the section related to the multi-layer description. We updated a mapping table for a specific pointing out a specific young models. And we updated a section to include discussion regarding specifically the transitional link discussion that is needed for multi-layer, and that has been one of the construct inside the construct inside the TA topology drafts. Okay, this is the picture of the model that we analyze and that are at the base of our work, both for topology, for tunnel, and the other new one with the service model, virtual network service model, path computation request, and schedule. So next step, general comment, feedback from the working group. And next step for plan is we think that this document could be a good input, a starting point for the new newly Ccamp design team. And the also in plan is obviously to following the different discussion on the different topics. For example, regarding path computation, but not only, and help in try to solve possible related issues. This draft is practically a try to summarize all the analysis and the different aspects also in the different topic for the young related draft. So it is essential to keep on dating that to include all the more information that is necessary. So this is the plan. Comments?
Can you go back to the previous slide? So in the other section, you have a couple of examples where you're taking a much richer model, carving out pieces of it, and creating a new model. So one example is you take the TE tunnel and carve out certain pieces of it, and you're creating a service model. Same with TE topology as a service. I'm not sure if there are other ways of doing that. So I'd like to see if anybody has any opinion on that.
Me or?
From the working group.
Yeah.
So do we need, the question is, do we need to use a new model, or are there provisions to make use of existing models? Because in essence, what you're doing is you're just taking certain leaves out of a much richer model and creating a smaller model and calling it a service model.
My answer that in the other there are already some models that is new one and that is being considered as needed to for extend what is already there. I don't know now if it is possible that some other young modeling can be needed, but at the moment I think that the picture is still is complete.
So couldn't you have just used the tunnel model as the service model?
Because there is also the service model that is proposed here, so the transport service model, and for that we think to go on in the work and try to define difference with respect to the tunnel model. This is the.
I would like to understand your concern in the sense that if I correctly understood, you would like to have a new model for the service instead of using a simpler version of the existing one.
So you seem to be already using a new model, and which is just a subset of an existing model, which is much more richer in features and capabilities. Is that what we want to do? Was the question. And we are doing it for the tunnel as well as for the topology.
There are two, let me say, service models that are considered here. One is technology specific, that is the OTN tunnel model that is augmented from.
That's fine. The technology specific models are fine.
Okay.
I'm just talking about the service models.
Yeah, for the other one, yes, my answer is that some work is needed. Some work is needed again, but yes, we would like to extend that.
I guess there's a design team in Ccamp now which is going to take a look into this. So we can probably have, I can send some inputs to that team, and then you guys can figure out what to do.
Yes and no, but I guess Lou is going to reply to you.
Actually, I'd like to hear from the Ccamp chairs what the design team scope is.
Hit me. Actually, this is a little bit borderline because I wouldn't say that the service model, the transport service model, falls in the NBI design team. This is something that is. And the reason being also the fact that it is a TS document is not something that falls in the Ccamp design team.
Right, that's what I was reacting to. I thought the design team was going to cover the gap analysis, is looking at it from different specific technology use cases and say, okay, we want to sanity check this use case against what's out there and what's missing, and that seems perfectly appropriate to do from a specific instantiation standpoint, or a specific technology.
Yes.
But the fallout from that, I would expect almost all of it to be generic, as in we're missing these big pieces or we're missing these little details. And if you get down to the little details, and then it's some way you identify an ODU or parameter, sure, that no question. But I think it's the bigger picture and the bigger gaps that are more interesting from the design team.
Probably this is one of the common cases where we have a generic box inside which we have all the technology-specific parts. I would say that here what we need is a TE service model, which is the generic part, and then we are going to augment it with the technology-specific parts. So probably we are still speaking about it's a 0-0 draft, if I correctly remember, an individual 0-0 draft. But my personal opinion is that this draft needs to be split into two parts and have a T service model and one or more technology-specific models. This is my opinion.
Yeah, could you define what is MBI? Transport MBI. I know, but where does it fit? Because I mean, we try to avoid this terminology, I think, for a long time, right?
Mm-hmm.
And in your document, you're talking about orchestrator to controller.
Mm-hmm.
So kind of MPI, kind of in ACTN.
Yeah.
Okay. So I think that it's recursive.
Yeah, is general term for to identify northbound.
Yeah, I think that's why I think Pavan's comment look like you need to distinguish which particular interface you're referring to for service model. You don't want to reinvent on T model on MPI, but if you're talking about different interface, like a T service model we talked about this morning in the T's working group. That's why I think MBI term, and then you put a service model all together, but some model doesn't belong here. So that's my comment. Do you understand my point?
Yeah. Yes,
Okay.
I understood.
Yeah, Haomian from Huawei. Again, based on this discussion, is it already agreed that different interface should have different kind of Yang model, or not?
What do you mean with the different interfaces?
I mean the so-called northbound interface and the interface from the controller to devices.
I would say they have to.
Okay.
Right. In one case, you are speaking to a node. In the other case, you are speaking to a controller. So I would expect to see a network model from one side and an equipment model from the other side.
I thought I wasn't going to disagree with you, but now I am. I think there is a difference between a service model and a device model, and whether that service model is implemented by a device or not. Well, everything's just a computer, right? Whether it's in the network or not. So I'm not sure about that last comment that you made, but I do see that there's a difference between a service model and a device model. And I understand it in the context of like L2 and L3 VPNs and services, that when you describe the service, you want to talk about the whole collection of pieces that make up the service, and then you may have some limited information you want in terms of provisioning PECE communication, like routing protocols, and you may not want to do the whole, specify everything, but in some cases you do, so you end up having to recreate basically the same information you have in a BGP model inside your service model. How's it going to play out for in the TE case? I don't know. We might end up with the same thing. The one thing I'll say is that may end up being different for us versus L3SM and L2SM is when L3SM got started, there wasn't something called schema mount. And now we have schema mount as a tool for basically taking a model that might otherwise have been on a device and bringing it into the service. Maybe that's a good way to reuse things and to think about that. But we're now talking about solutions when this draft and the work and the design team we're talking about is really focused on gaps. And it'd be really good to make sure that this work of the analysis of what's missing focuses on what's missing versus how to solve what's missing, because there are multiple ways of doing it. So it'd be really good to hear a focused statement of what's missing to do the full technology specific service you're looking at.
Agree with you. Other questions? Okay.
Yeah, we'll skip the next item on the agenda. We don't have the presenter here. So,
and we already gave away the minutes dedicated to that slot.
Gabriel.
Good morning, this is Gabriele speaking, and I talk on behalf of the group of editors and the authors, Rudiger, Darini, and Gert. This document is coming from a discussion we got in IETF 96, where the DWDM interface framework document has been promoted to working group document. And so we decided to go forward describing the interfaces, the DWDM interfaces, and also to describe what were actually the description of the problem we are facing with this kind of interfaces in the industry and in the operator. So basically, what happens here? We are talking about 100 gig and beyond DWDM interfaces, which are, if you want, coherent interfaces, and they are not yet fully specified by ITUT. ITUT is working, but is not yet ready to give all of us a set of optical parameters that should be or must be used in order to manage or to understand what kind of interface is fitting in an equipment. Equipment that can be either a DWDM box or an external box, like, for example, a router or an OTN machine, whatever. So the point is, if we want to specify this bunch of parameters that are quite many, we can either refer to the ITUT existing parameters plus a set of not yet or under specification parameters that let's say will be shared to get the network topology, to maintain and to provision the interfaces into the box. This, of course, lead to have this document not as a recommendation or a normative, but at least as experimental or informational. This is because actually we saw that there are already many implementations running, And also there are many consortia that actually are trying to define those parameters their own. No? And so here the feeling is the industry and the operator are starting working outside standard body like IETF, and then they are trying to define their own parameters, and probably they are not really willing to present or propose those set of parameters to IETF. So, having said that, this draft refers the management, the DWDM interface management control and the framework that is a working group document. And also you will see another document in Ccamp, which is draft many coherent DWDM interface control, where we describe what are the issues we are facing. And finally, there is another draft posted, which is not going to be presented today or on the next section, and is related to the interface, or sorry, to the impairment validation parameters along the network. Just to be clear, what this draft is talking to is basically related to this kind of interface, this interface. So the DWDM interface with 100 gig and beyond, and wants to specify or to model the parameter that should be consumed or get or provisioned by an SDN controller, whatever it is. We do not specify the parameters inside the network, and the use case could be to have, of course, a multi-vendor network like B1 for the transponders, B2 or C2 for the optical network, and another one for the other transponder. As I just listed the parameters that are specified by the draft, and I don't want to go through the list because it's quite, if you want, boring in this discussion. But of course, is a list that should be very carefully read and clean. So the next step or the key requirements are, of course, we want to simplify the management and the control of the network. I remind you that those parameters can be used by an SDN controller for a DWDM network if the SDN controller wants to check the optical feasibility. Otherwise, it doesn't have any clue. And doing that, the SDN controller can automate operation, maintenance, but also, for example, new circuit or even restoration. Of course, a precondition is that we have a data plane interoperability among the vendors. And so that's it. Next step. I think we should look at carefully those parameters and try to help to clean up the parameters, because maybe we have more parameters than needed, or maybe we have less parameters than needed. We deliver a further version of this document with the cleanup, and of course the discussion is very welcome. Thank you. Thank you very much.
Any questions, comments?
Looks like it's a scaring method, this one.
Dieter Bellanok here. I read the draft, and I also looked at the tree view of the Yang model. As far as I could see, it only defines.
The three should be related to the IETF interface Yang, or interface IETF Yang, whatever. If not correct, we have to fix it.
Yeah, my question was that as far as I have seen, it defines the application codes, it defines frequency, input power, output power, which are the parameters that are defined also by the IETF recommendation,
Yes.
which is fine. But you mentioned here that you're going beyond that. So
yes, we are going beyond. Like, for
but that's
example,
not yet in the current version of the draft.
in the draft now you have modulation format, you have and some other. But in any case, Dieter, I would like really to have an help from your side to clean up the document. That is.
Okay. I think we will have to discuss
Yes,
that anyway
yes.
in the Ccamp session. When is that? Wednesday or Thursday?
Thursday.
Thursday. Yeah, okay.
Thank you. Thank you.
Yeah, we do have a slight change in the agenda. Apologize for that. The L1 topology is back on the agenda now. We have a substitute presenter. Italo Busi would do that.
Thank you. I'm Italo Busi from Huawei. I've been asked to present these slides in the name of the authors. So the scope of this slide is to define the OTN topology model, and it will fit into the current Yang architecture as extending the generic T topology model Shufeng has presented earlier, which is also augmenting the network and topology model from RTOS. So it's this is the location of the draft, and it's a Ccamp targeted draft for the elliptical layer of the OTN topology. What we have done since the last IETF meeting, there was some updates. So we got some comments from the mailing list, and based on these comments, we have updated the description of the available bandwidth as a set of, as a list of audio type and the number of available audio per type. And also the IAM model is related to describe the available bandwidth in terms of per priority, so to have different available bandwidth on different priority levels. And we got some suggestion from Humor how to improve the text, and we got some update to the text through all the draft based on his comments. And an example on how to use this model has been also added. It was very simple, just to help people to understand that. And Ub has been added as contributor, given his feedback. And in the last version from 04 to 05, there has been some minor fixes. So this is more or less the work that has been done since the last IETF meeting. So what we could, the next steps, there's seen some interest and comments on the mailing list and interest. So we think that the document is really for being adopted as a working group document. So we are going to ask that. That's all.
While Lou is going to the mic, before Feng said that technology-specific parts were removed from the T topology draft, were those parts embedded here? Is there a plan to introduce them somewhere?
Yeah, I think the OTN specific, if they are not here, they should be here.
Okay.
Lou Berger. I'm confused by a couple of things, and I think they're like really, really minor and easy to fix. The first is on the first slide. This says layer 1 and then OTN. So is that just because you work in OTN, so that means layer 1 is equivalent to OTN? I mean, layer 1 is bigger than OTN. So is it simply really that you mean? I think you really just mean OTN, not
yes,
layer 1.
The draft only mean OTN. The elliptical layer of OTN.
Yeah, so if and when this becomes a Ccamp draft, which I would expect it to be, just change it layer 1 to OTN and drop out layer 1.
So it's going to be kind of draft IETF Ccamp OTN topology.
That would be my request.
Okay.
To be even more correct, ODU.
Yes, exactly.
Oh, even better. I do like that.
The
other
scope is
thing-
clearly is what is has written this very clearly, but okay, I understand your point.
So the draft is really clear except for 2 spots. It mentions MPLS-TP. Why?
Oh, okay.
So Tian.
Seriously, why?
Okay.
It's really bizarre. I don't get it.
I think it was just introductory test about where OTM fits. I read it, and it's just about introductory test about where OTM fits into the overall transport. But
Okay, I think it does the opposite of clarity. So please
okay.
just drop that.
Point taken. Okay.
Thank you.
Amy?
Hello, I'm Amy from Huawei. I'm here to present a work from our microwave design team. And we have 2 output right now. One is the framework document, and today I'm here to talk about the young model draft. So that's the current author for this young draft. And just give you some background information. So this draft is just to define a young data model in order to control and management the radio link interface, and also the connectivity from the client interface to radio interface. Typically, that will be Ethernet. And another clarification is that this young model doesn't include some wireless access technology, for example, the base station. So that part is not included. And the young model draft, we will follow the framework defined in MWDT Ccamp framework. So, and we will argument based on RFC 7223. And we will use the structure in a previous individual draft. It's in Ccamp. And for the parameter definition, we will use the parameter definitions in the individual draft. And also there's some ongoing work in ONF. We will also take reference from that. And we will, based on this information input, we will need to fill out the gaps which is identified in the framework document. That's the scope of this model. So if you could take a look at this figure below, it's taken from the framework draft. It's, for example, connectivity from the Ethernet port to radio link terminal and further to carrier terminal. That's the current layers of the microwave equipment. And in that sense, we have several sections for the young model. One is radio link config and state, and also carrier termination config state. And we also plan to have some protection. This is radio protection. It's have some similarity, but have some technology specific items on its radio configuration. And we will also have some radio groups such as XPIC. It's a technology widely used in microwave technology, and also MIMO. It's MIMO in microwave, and not the MIMO in the wireless, but have some similarity between them. So that's the scope of this draft. And that's the current definition for the young model. In the current version, we just include the definition in the carrier termination config because we are running out of time before the deadline. But we were going to have a side discussion, several side discussion this week to finalize. And the next step, we would like to maybe ask to be adopted by working groups because it's a starting point to continue. finalize the work. And also, of course, review and comments are always always welcome. And we will have several side discussion, and anybody who is interested, you're welcome to join us. So that's my discussion.
Thank you very much.
So we had one more Ccamp draft on the agenda, but we wouldn't be covering it. We don't have the author here. We don't have a substitute either. So we'll now move on to the Yang path computation draft.
Okay, thank you. I'm presenting together with a draft we prepared together with other co-authors. I am Italo Busi from Huawei. What is the status of this draft? We presented the initial idea about the need for having a path computation via Yang request via Yang model in the last meeting in Berlin. There was targeted to the Ccamp working group, since we were seeing this some major priority for having this capability for the optical transport network. And we have updated this draft for this meeting based on the comments we have received at that time. One change was to move this draft to the TIS working group, since people expressed an interest to have it a more generic approach than just optical network. We have a little bit restructured the draft outline to clarify the different aspects we were dealing with. And we have added some text to clarify also where which interface we are targeting with this draft, referring the AVNO and the ACTN architecture, just to reference existing architecture and to say on which side part of the architecture this draft is targeting to. And also we have added more text, some text describing why, in addition to path computation requests between controllers, we want this to be done in Yang. So the scope for this is to describe the use cases where do we need the capability to request path computation via a Yang-based protocol, which could be netconf or resconf. And we are targeting an interface which is between on top of controller, on the north side of a controller, which can be an MPI or a CMI in the ACTN context, or it can be a VNO control interface in the AVNO architecture. And the outline has been clarified, so we have a little bit split. Section number 2 is describing what are the use cases we see and where this capability can be needed. In section 3, we describe more why we think that even if having an abstract topology provided by the underlying controller is still not sufficient, so even in that case, we need to have this capability. The section number 4 goes into more details about why this capability has to be done in Yang instead of other protocols. We want to add in the future version some concept about path optimization, but this is still an empty section. And we are starting a new section 6 where we start analyzing the discussion about the possible solutions. So the use cases that we have identified in this section, I will go a little bit quick for sake of time, are an IP plus optical solution where we have an optical controller, an optical domain controller providing connectivity, providing information to an end-to-end network orchestrator to have an optical connectivity between IP routers. And the second use case is when you want to create a multi-domain TE network, and for example, a multi-domain optical network, and you have to set up the optimal end-to-end paths across different domains. And the third case is similar to the first one, is providing interconnection between data centers through a TE network, and the optimal path needs to take into account not only the traffic engineering cost of the network, but also the computing cost of the data center. So somebody has to stitch together the information coming from the network and the data centers. And in these slides, you can see exactly what is the interface we are targeting. So in the first case is the interface between the orchestrator and the optical domain controller, where you can request and know what is going to be the cost of the possible paths you need from the optical network. In the multi-domain is between the orchestrator and the different domain controllers. And in the data center is still between the orchestrator and the T network controller. And so that's about the use cases. In this analysis, one argument we got was, well, you can get all the information from T topology and use path computation in the orchestrator to do the end-to-end path. But in the document, we see that even if we do that, so even if we extend the T topology with all the detailed connectivity metrics, we have some problems to provide all the information that might be needed. The information may be too much and quite unscalable. So by analysis, we think that there is a real trade-off in a real network between being accurate in what we provide to the upper layer controller or be scalable. We can provide a lot in unscalable information, or we can provide less information, but then we are not fully accurate. And so we don't provide enough information to the upper layer controller to make optimal decision. Or even if we are very accurate, we have a problem to keep it up to date information, because as soon as the information changes, we take a lot of time to update the higher layer controller. So there is a trade-off between these entities, and if we add, in addition to T topology, the capability to request path computation when you need it, so you can ask what you need and when you need it, then you can help trade off a bit, so you can live with less information and get the information accurate and updated information that you need when you need it. Nevertheless, we think that providing answer topology information is still a useful information that needs to be supported between this controller, especially when we have a big network with many domains. The number of path computation requests that you have to do end-to-end path computation may be too big. So also only using path computation is not going to scale. So the idea is use topology. What we propose in the draft is use topology and path computation as complementary tool. You can use a T topology information to understand a potential limited number of domains that may be candidate for the end-to-end path, and use path computation to fine-tune which is the best path among these with this subset of candidates. So in this way, you can scale both in the number of topology, in the status of the topology information you have to provide, and as well as the number of requests that you need to ask. The section 4 is also addressing why to do that we need a young model, and the reason is that on that interface between the different controllers, we already have a young model for topology information exchange, and we will use a young model for the T-tunnel setup, which was discussed before by Rakesh as well. And the path computation request should have a consistent request. So when we request what will be the result of, if we ask, I'm going to set up this path, then it has to have the same understanding of both, of who is requesting and who is replying. So it is very important to have a common data model. So we have the same name of the ID and the same structure to describe what are going to be the path constraints. So for this reason, we think that the path computation has to be done in Yang, first of all, and second, the attributes have to be in common with the T model to ensure consistency. Another motivation is to have a single interface between the two controllers, which make very easier to authenticate the two speakers. You don't have to set up many protocols and many authentication sessions. You can keep consistency between the different information exchanges of the different between the two entities, because it's still the same two entities that are talking each other. It's simple to test because you can use only one protocol to test. You are also more friendly to some middle boxes doing some load balancing or some firewalling, etc. And you can leverage all the Yang ecosystem in terms of tools, debugging, and all this stuff. And as we said, that the YANG language is nowadays mainstream in the industry to support many capabilities between the two controllers, so service configuration, topology, performance, OIM, and QS, and this is going to be just one bit to add to the whole set of YANG models that have to be supported between these controllers. So these are the main technical motivation we have seen to have this, the possibility to request part computation via YANG on that specific interface for that specific use cases. For the YANG model, there is an ongoing discussion. We have seen a lot of email exchange in the last few weeks, and also some discussion this morning and before when we discussed the tunnel model. Today, what we notice, we have tracked in the document is what is the current status, what was the current status at the time we wrote the document, which were the cutoff deadline. So at that time, the idea was that we have the tunnel model is describing the computing tunnel, the computed tunnel tunnel setup, which is a stateful solution, which has some drawbacks being stateful. So, and there were recognition that there is a need to have a stateless solution, which is much simpler, more natural in many of the use cases that are described in our draft. And there was some work done between co-authors to develop an initial proposal for a YANG model, which is available on GitHub. Unfortunately, we had some troubles with the uploading, so it's not yet in the draft. We are planning to add it to the 0.1 draft, also based on our discussion. And as again, we think that compute-only and stateless RPC are approaches that both has to be supported because they have some pros and cons, and depends on the real deployment scenario, which one is going to be better to suited. So some thoughts. What is the advantage of the stateless RPC is that is a simple atomic operation, and where you request a path and you get the path. It's a very natural choice, especially if you have a stateless PC underneath of it. You request and you get the answer, you have finished. No status to maintain. So you need to maintain any persistent storage in the underlying controller. And even more important is there is no state, you don't have to be any garbage collection. What happens if somebody asks you to set up a pre-computed tunnel and never delete it? So you don't have this problem because it's stateless. On the cons, where some discussion ongoing also in the weekly conference call with the T-tunnel is that the RPC may not be, response may not be synchronous, especially if providing the answer to the question is time consuming. The server controller may not be able to reply immediately. There is still discussion about how to solve this problem. There is people in the co-authors team that believe that this can be solved, but we still don't have a complete description about how this could be done. And another problem is that there is, since it is stateless, there is no guarantee that once you request a path, and then later on you request the path computation, later on you request to set up the tunnel using that path may not be longer available. Because by the time you request and the time you set up, something can happen in the network. You cannot guarantee that the path is available. That of course, we have some text in the draft. That also depends on how wide is this time window between the time you request the path computation and the time you actually try to set up this path. For the compute-only T-tunnel, we think the pros is that it supports the asynchronous operations natively. It's also simpler to model, considering the current T model, because it's just adding an attribute to an existing tunnel model. While on the other case, we have to develop a new RPC by copying or referencing the existing attributes. And you remember at the beginning, I was saying it's important to keep consistency in the attributes that we are defining for path computation. And also, as another pro, you can have notification. So after you request a path computation, if the path changes, you can have a notification that tells you that the path that has been previously computed has been changed. But what is the cons? The cons is that you have to create, you have more messages than a single RPC to get the same action. Because with a stateless RPC, you request the path, you get the path. With a concurrent, you have to create a new tunnel. You have to get the path, and then you have to delay the tunnel when you don't need it. So you have to do 3 operations instead of 1 for getting the same information. You need to keep a storage, so you are consuming states. And you have also to provide, you have to figure out how to do garbage collection. What happens if somebody does not delete a tunnel you don't longer need it? And you have also a lot of, you're putting some burden to the processing of the underlying controller, which has to keep track of all the changes which are affecting all the tunnels, which are creating a pro-computing model, and is going to notify the client controller that the tunnel path has changed. And also the notification is helping to solve the problem, but it's still not solving the problem. There is still a probability, even if you have a pre-computed path, there is still a probability that when you instantiate that path is no longer available because something has changed and you have not yet been already notified. So you are making, the window can be shorter, but it's still, so it's helping to solve the problem, but it's not definitely solving the problem in every possible cases. So what are the next steps? The next steps is we would like to get more comments and feedbacks from all the interesting working groups. We already got some feedbacks. For example, some information in the draft is duplicating information which is available in other drafts or in other RCs. So we are willing to work with people to clean up and to avoid, we don't like to duplicate text. The second comment, we want to track the discussion which is ongoing on the mailing list about the RPC versus T-tunnel, and to line up with the T-tunnel authors to see also where the YAM model, whether the RPC will fit, and then we want to add some work on the path optimization. So that's complete my presentation about where we are and where we want to go for the next phase.
Yeah, we don't have time for questions.
Oh, okay. So on the
so
list,
if anybody has questions, please do take it to the list. There is a good thread going on already, so please contribute to it. Next presenter, please. Sure. So I think that thread currently is, I mean, folks are sending it to multiple working groups. Yeah. Stick to T's, I guess that's where this document is.
So your suggestion is to shrink the discussion to only the T's working group mailing list? Okay, yeah, we will do that. Thank you.
Good afternoon. I'm Jianzhou Fu from Huawei company. Today I have two YAM model about IP plus protocols. This first is IP link and transport service mapping. This is the new draft. You can find the link at here. This draft is based on the framework proposed in IETF's ACTN framework. The draft presents some special information about IP plus protocol solutions. In these solutions, the mapping between IP link and transport service is key point. So the draft provides a YAM model for IP link and transport service mapping, which defines not-bounded space for MDIC. Here's IP plus protocol target solutions. Or YAM model is at the MDIC not-bounded space. Why we need the YAM model? Here may be more scenarios. Here I just give one example. First, multiple service path visualizations. Then we want to see, we can get more information from the YAM model, such as IP link, transport service, and their mapping. Based on this information, we can visualize multi-line service paths. Second, multi-line maintenance window. Sometimes maybe we want to maintain some nodes or links, so we should know which service or IP link or transport service can be impacted, so we can avoid it. That means we can get this information from this YAM model. The third is we can use YAM model. We can configure, we can use Yang model configure these mapping, IP link and transport service. So that means we can from CNC or APP, we can configure Yang model at MDIC. Then MDIC can coordinate IP PNC and optical PNC to do this work. Otherwise, maybe we need two APP to separate do the same work. How many kinds of mapping relations? Here I give three basic mapping. First is one-to-one. That means one IP link mapped to one transport service. Transport service will use the physical port. IP link use the same. The second is N2N. That means there are multiple IP links mapped to the same transport service. The transport service also use the physical port. So IP link will sell the same physical port. Also, we can see each IP link as a VLAN port. The third is one-to-one. Means one IP link mapped to different transport service. Each transport service have different physical ports. So we can consider IP link as Ethernet trunk. So the information about mapping relations, here I just give some basic information. More information also should be added. First is port setters. IP link or transport service should have the operation setters, admin setters. Second is bandwidth. Bandwidth also is very important. IP link bandwidth, transport service bandwidth, and also important one is how IP link map to transport service mapping, the mapping mode. The third is SRLG and latency. Usually, we should configure SRLG or latency at the IP link manually. If we have this mapping, IP link can reuse SRLG and latency from transport service. Here's model. Okay, that's all. Any comments? Question?
Sergio Belotti from Nokia. In your document, you provide a mapping between a client IP link and the server tunnel, practically. So the server transport tunnel. So what is
I'm sorry to cut you off. Can you send your question to the list, please? We have 3 minutes and one more presentation to go.
Okay.
Thank you. Can we have the next presenter, please?
Okay. This model is for VNT protection group. There also is a new one. The same, we follow the same framework. In this one, we give some special information about IP and plus optical solutions. That we provide a protect mechanism for IP layer. That means that is VNT protection. So the model, we provide the model for VNT protection group. We also define the NBI for MDIC. What is VNT? Please refer to the RFC 5623. VNT function is planning virtual IP links. So, routed ports and optical resource can form the VNT resource pools that can provide the VNT link on demand. VNT also can be added, deleted, or modified. What's the VNT protection group? The VNT protection group can provide protection mechanism of IP layer, active protection link when work link failure of some other region. Configuration support one-to-one, one end-to-one. See, look these two pictures. At first, there are no IP link among these routers. According to optical resource, we can plan VNT link. For example, the green color and the red color. We also can plan VNT protection link, the blue colors. The blue color protects the red color. Both of them use the same physical port. The difference between VNT protection and IP protection. Traditionally, IP protection or restoration use the IPFR or IGP convergences. It doesn't consider transport service or optical service, optical resource. So sometimes maybe there are no IP link for some end-to-end service. That means the service will be impacted. VNT protection in IP and the optical solution, they will consider the optical resource. So the protection will involve the creation and the deletion of transport service. Also, they also will use the optical resource and the root port. So the protection will be protected properly. Here is the example. At first, we will plan the VNT link and configure it. Also, we will configure the protection group. Then active the VNT link. That means IP link up. When one node crash, that means IP link down. VNT link will be failure. So VNT protect link will be active. So the service can go to this new IP link. Okay, that's all. Comments?
I have a question. Why are these PCE drafts and not these, for example? No, I mean the draft. Why did you publish these drafts as PCE documents in the PCE working group and not in this working group?
Because this IP plus optical solution, normally we use PCE name.
Yeah, so speaking as PCE chair, I think that both of these drafts would fit better inside T's because I think they're talking more about network architectures, and in PCE we focus on standardizing extensions to PCE protocol, and I don't think these Yang models really are directly applicable to PCE protocol. I think they're more general. So I don't have any issue with the models themselves, but I think you should try to discuss them on the T's mailing list in the T's working group, not in PCE as a first step.
I'm not getting what is the question.
So I think PCE working group is the wrong working group to do this work in. I think that you should look at the T's working group. TEAS, T's.
Yes.
Yeah. This guy.
Wrong chairman.
Yeah.
So this is it. Thank you very much for attending. We will meet again with Ccamp on Thursday. And for the rest of you that will not be in Ccamp, see you in US.